Right, year 11s. This is exercise 3I, question 12. I'm going to show you how I'm going to do this question here. So let's have a look. You got x squared plus 4m times x plus 24m minus 44. They want you to find the discriminant, which I'm going to pretend this is a quadratic equation. And we know that in a quadratic equation, it will always have an ax squared plus bx plus c. So a is the number of times to x squared, b is the number that's times to x, and c is the one without an x, right? So I can see here that 1, even though we don't write it, it's actually, that's my a value there. B is what you're multiplying to x, which is 4m. And you got c, which is 24m minus 44, because that doesn't have an x in it at all, yeah? So discriminant, which is given by b squared minus 4ac, can then be simplified to 4m squared minus 4 times 1 times 24m minus 44, which gives you 16m squared, and that's minus 4. Now, I also noticed that 24m and 44, you can factorize that even further. So if you think about it, you can factorize that to take out the 4, and you got 6m minus 11. True? Okay, so notice that's 4 times 1, which is 4, and then I just factorize the inside brackets there to give you this. So ultimately, what I have is 16m squared minus now 4, expanding the brackets, 4 times 4 becomes 16, brackets 6m minus 11, right? But also conveniently as well, I also notice again, they both have a factor of 16, so I can take out 16 as my common factor, and that becomes 16 m squared minus, and this is my other bracket, that's 6m minus 11. If I sort of expand the negatives, so multiply the negatives out, I get now m squared minus 6m plus 11, because negative times negative 11 becomes positive 11, yeah? That's why it's important to make sure that you've got your brackets correctly, otherwise you would have a minus 11. But there you go, this is my discriminant. I've sort of factorized it all, that gives you my discriminant there, okay? Now, answering the question B, B says, show that the equation, which is the discriminant, the equation x squared plus 4mx plus 24m minus 44, you want that to have a solution for all values of m. Okay, so for all of m. What that basically means, remember, a solution means that you have an x-intercept. So they're saying that it doesn't matter what m, for all m values, any m value you choose, or any number that you choose for m, you should get an x-intercept, regardless. So it could be 2 x-intercepts, or you can have 1 x-intercept. But regardless, the only way to have 2 or 1 x-intercept is the discriminant needs to be positive, so it's bigger than 0, or it equals to 0 at the very minimum to have an x-intercept. Yeah? So what you're really wanting to show in B is that you want to show the discriminant to be bigger than or equal to 0, and we know that the discriminant we just figured out before was m squared minus 6m plus 11. We want that to be greater than or equal to 0. True? Now we can show, if we can somehow show that this equation is always going to be bigger than or equal to 0, then you've achieved your goal. My tip, as always, is try to sketch this graph. Now, when I'm sketching this graph, as you can see, it's hard to tell much from it unless you factorize it. Now I can see that 11 and 1 is never going to give me that negative 6. So what I'm going to do is I'm going to complete the square of m squared minus 6m plus 11. And hopefully you remember, if this is a minus 6m, the last term I need has to be a plus 9. Okay, because half the negative 6 gives you negative 3. Negative 3 squared is plus 9. So I need that to be plus 1, but I don't have that. I've got a plus 11. So I'm going to put in plus 9, minus 9, and I get a... Hello, I'm just recording.
Is Compass back?
No, oh yeah, Compass is back. I'm just doing a recording. right now in the video. Well, now you're on the video. So you got m squared minus 6m plus 9 minus 9, and you've got a plus 11, and that now gives you this is factorized to as a completed perfect square. You get m minus 3 all squared, and you got negative 9 plus 11, which is plus 2. And you get a 16 on the outside. Now you want all of this to be greater than or equal to 0. And here we go. We're going to expand the bracket. 16 times the bracket and 16 times the 2. You get 32. 16 m minus 3 squared. So I've completed the square. And it's all about sketching this equation. Now using what you learnt in exercise 3D, we can read the equation. You've got 16 bracket m minus 3 squared plus 32. We can see this tells us it's going up by 32. This tells us it's narrow. And it's a positive value, so that means it's a smiley face. And you can tell m minus 3, if you solve for m, that gives you 3, so that tells me to the right by 3. So if I want to roughly sketch this graph, what I have now is to the right by 3, so to the right by 3, up by 32, so let's say up 32, that's where my turning point is, and it's a narrow smiling graph. Let me just fix that. Narrow, and it's a smiley graph. There we go. And what you can see is that from the graph, doesn't matter what m values you choose, the discriminant or the coordinates on the graph always correspond to a positive discriminant. Because it's always a positive discriminant, that means the discriminant is always greater than 0, and if it's greater than 0, you will always have 2 x-intercepts. Okay? So to answer the question for B, what you would say is, so you can say from the graph, you can say from the graph, since discriminant is always greater than 0 for all m values, this means that you will have 2 solutions or x-intercepts for any m value. There you go. So that's question 12 of exercise 3I. Hopefully you've watched my other videos on question 5 as well, and it should give you a better idea of how to do discriminants with quadratic equations. Okay? Thanks for watching. Let me